In this video, we're going to talk about patterns and sequences. Some vocabulary you'll need to know is arithmetic sequence, which is a sequence of numbers formed by adding the same number to the previous number. So this includes adding negative numbers. A common difference is the number that you are adding to each term in the arithmetic sequence. A geometric sequence is a series of numbers formed by multiplying the same number to the previous numbers. This includes multiplying by a fraction. A common ratio is the number that you are multiplying to each term in the geometric sequence. Another way to think of a sequence is like a function. The first value is your input or x value. The following value is the output or the y value. So the first value is your input. The following value is your output. Let's try an example. In this example, you notice that going from 5 to 15 to a blank to 35. If I try adding, I would add 10, and then if I added 10 to that, I would get 25, and if I added 10 to that, I would get 35. So it stays true throughout the entire sequence. So this is going to be considered an arithmetic sequence, or a common difference of plus 10, which the expression or the rule is going to be x plus 10, x representing the previous number. So your input, if you start with a 5, like we did, we added 10 and got 15. So then you write your 15, add 10, you get 25. Bring your 25 down here. You're at 25, you add 10, you get 35. Bring your 35 down. You add 10 to 35 and you get 45. So this is when you're adding a positive number, and this is an example of an arithmetic sequence. So now let's look at adding a negative number. To go from 54 to 49, I'm subtracting 5. Okay, or in other words, adding a negative 5. So to go from 39, if I add a negative 5, I get 34. So this is still a common difference because it's arithmetic. I'm adding, and I'm adding a negative 5. So my rule would be x plus negative 5. So in my table, 54 is my x, my outcome was 49. So when 49 is my x, my outcome is 44. When 44 is my x, and I add negative 5 to it, I get 39. When 39 is my x, I add negative 5 to it and get 34. Let's turn the page for more practice. So these are examples of a geometric sequence, because you are either multiplying by an integer or by a fraction. So to go from 1 to -5, I'm going to multiply by -5. -5 times -5 is a positive 25. 25 times -5 is a -125. Times -5 is a 625. So each time you're multiplying by -5. So that is a common ratio. You're multiplying by -5, and the expression is -5x. So I'm starting with 1 times -5 is -5. So then I get 25, -125, and 625. And example 4, to go from 28 to 14, I am cutting that in half. So I'm going to be multiplying by 1/2. You cannot say dividing by 2. 14 times 1/2 is 7. 7 times 1/2 is 3.5. So this is a common ratio, and the rule is 1/2 x or x over 2. Either one is fine. In table format, you start with your 28, you multiply it by 1/2, you get 14. You multiply that by 1/2, you get 7. Multiply that by 1/2, you get 3.5. And if you multiply that by 1/2, you get 1.75. You can also put these in fraction form. Ask your teacher what they prefer. Try number 5 on your own. It gives you tables to show all your work in for each sequence. So sequence 1, you're going to show your work for your input-output table here to see what you did. Table 2, you're going to take for sequence 2 and show all your work here. And table 3 is sequence 3, and you're going to find the rule using this sequence here. If we did sequence 1 together, I start with 13. In order to get to 26, let's reword this. Which sequence follows the expression n minus 13? So that's what's going to go right here. Okay, and that's what you're going to follow for each sequence. So if I plugged in 13 minus 13, I would get 0. 0 is not my next number on my sequence. So my next value is a 26. 26 minus 13 is 13, which again is not my next number on my sequence. If I plugged in 52, I would get 39, which is not the next number on my sequence. So you can see that this does not follow the rule of n minus 13. So sequence 1 is out. In sequence 2, I'm starting with, again, 13. 13 minus 13 is 0, which is not my next output. So let's keep going just to check. 26 minus 13 is 13, which is again not the next outcome. 39 minus 13 is 26, which is not the next outcome. So as you can see, once you've got 2 or 3 of these that are not following the outcome, you know that's not following the right rule. And the following sequence, I start with 1,000. 1,000 minus 13 is 987. That is the next value. 987 minus 13 is 974. That does work. 974 minus 13 is 961. So you can see sequence 3 is my answer because it follows the rule of n minus 13. Ask your teacher if you have any questions.